All right, this is AP Pre-Calc. This is our 1.1 lesson. This is what's called change in tandem. But really all we're looking at is a bunch of definitions for functions. These definitions are definitions that we really need to understand the difference between them. Each definition themselves isn't super complicated. It's stuff we've probably heard of before. But the wording of these definitions can sometimes get confusing and people can mix them together. So we need to make sure that we understand the difference in each of these definitions. First one, if you say a graph is increasing, right? If I asked you what that was, you could probably show that to me with your hand. You could draw something like that, right? Your graph is going up. But what we really mean by that is as the input values increase. That means as your graph goes right, the output values, now that's the y values, right? Input is x, output is y. Well, now your y values are also increasing. So as your x increased, meaning it went right, the y values increase, meaning your graph goes up. Same idea for decreasing. You could model that for me. You'd probably say it goes down. But more specifically, that definition is the input values increase, so the x values are still going right. But now, since we're decreasing, that means the output values are always decreasing. In other words, the y values must be going down. Okay, so two very straightforward definitions for increase and decrease. The two that start to mess people up are when you start talking about concavity. Concavity, you may have heard of before. Concave up, sometimes people describe that with a U shape, right? Looks like a little bowl, and concave down is just the flip of that. But it doesn't actually have to be that full U shape. Concave up could still be a graph like this, where it's just maybe the right side or just the left side. Those are both still concave up. And same idea with concave down, you might have something that's just either side of the U or N shape that you have. Well, the reason we're allowed to have these other options as well is concave up is described as the rate of change is increasing. That's a little weird to understand for a lot of people. So let's go off on a little tangent and start to talk about that. So if we say that we just have some function, right? Here is our graph. Let's start to analyze this graph. Well, remember rate of change. Rate of change is just the idea of slope. It's how fast your graph is going up, how fast your graph is going down. So if I were to go from left to right on this graph, analyzing its slope, one thing you might notice is if I find 2 points on this left side, I look at the slope, that's a very negative slope, right? It's decreasing very fastly. But what we need to show is the rate of change is increasing. So right now, this is a very negative slope. Let's try another slope as we continue to move right. If I connect these 2 points now, notice their slope is less negative. Well, that means we went from very negative to less negative. In other words, your slope must be increasing. As you continue, you can start to draw more and more lines. You'll get to this spot, less negative. You'll even get to over here then, where it becomes positive. It becomes more positive, right? And as you go around, you notice your slope was decreasing slower and slower until it began to increase faster and faster. That's because of how we define concavity. Concave up is the rate of change is increasing. Concave down is that same idea, but your rate of change is now decreasing. So as it is, if you were to look at a graph similar to what we did there, as your graph goes up, it goes up slower and slower until eventually it turns around and begins going down faster and faster. your rate in which it went up slowed, and then it went down faster, so it was decreasing rate of change. Those are the definitions that a lot of people struggled with last year in AP Pre-Calc. Those are the definitions we want to make sure that we understand the wording for. Let's look at an example now. If we want to talk about the intervals that this stuff is happening, that means we're talking about the domain. If you don't remember, domain is purely talking about your x values in which something is occurring. So all of the values we're listing on this page are all going to be x values. If I want to see where something is increasing versus decreasing, that should be pretty straightforward. Just where does your graph go up or where does it go down? Well, if we look at the start of this graph, I notice originally my graph goes down all the way to right here. So we need to know then, what interval was it decreasing at? Well, it started at the x value of -5, and it decreased all the way to this x value of -1. That is your domain in which there is a decreasing section. If we continue to look at this graph, it hit that point, it went up for just a moment, before again it starts to turn back down. And then it changes directions, it goes back up as well. So there are some other increasing and decreasing sections. The increasing section, we said, started at -1, and notice now this section, it's in between -1 and 0. From there, our graph went down. So starting at 0, it decreased, it went down all the way over to here where your x value would be 3. And then it started to go up, so your increasing section would go up from 3 all the way over to here, which it looks like is 6. Increasing and decreasing should be pretty straightforward to find on your graph. Just seeing whether it goes up or down. We'll look at doing that stuff with tables later on too. The other thing we're looking at is h is concave up, right? So notice these are all talking about the function that is shown. So h is concave up. Well, if I look at my graph, right, I might be looking for one of these little sweeping sections or one of these U sections. And I see this U section here. So we just need the interval in which that's occurring, and it looks like it began its concavity between these 2 points. So +1 to 6. Some of you might say, well, this looks like it could be concave up right here. And it has that little V section. Maybe that's concave up. Well, we said concavity is defined by the change in rate of change, right? It's either increasing or decreasing rate of change. Well, if you were to draw those lines like we did on the parabolas, what you would notice is the first line just stays on there, right? I can't draw another line. In other words, this section of the graph doesn't have a changing rate of change, right? That is a linear section. It's a constant rate of change. Because it is constant, we know that linear sections cannot have any concavity. So that is the only section that is concave up. Let's go ahead, let's look at those next 2 parts. Next 2 parts then. The function h is both increasing and concave down. You might look at the concave down part. That'd be right here. Red probably was not my best choice in color. Let's go orange. I don't know if that's any better, but we'll use it. Okay, so we're looking at that middle section that is concave down right there. We also need it to be increasing though. Well, notice as your graph goes up, it then starts to go back down, right? So we only want the part that it was increasing on, meaning we want the part that was bound between those 2 values. I believe that would be -1 to 0. The last question on there then, both decreasing and concave up. Go back to your concave up section and find where it is also decreasing. It is going down. Well, I believe that would be here to here then. So I think our values would be 1, 2, 3, And again, we are just looking at the domain. We're just looking at the x values. That gives us a good intro into some of the different vocab that we need to have for the class. Again, this stuff for pre-calc is super, super important. We need to understand the different ideas in each of these definitions. We'll continue to talk about those throughout the year.